Moon phases day 6, April 2nd. Here's today's question at the top, the learning target, and key vocabulary. Starting at the lesson introduction, previously we learned the names of the moon phases and practiced identifying what phase we will see from Earth based off of different models. Our focus has been on how the moon's 29.5-day orbit or revolution around Earth allows us to see different amounts of light reflected by the moon. Today we will learn how the moon's location changes over hours instead of looking at day-to-day changes. This link right here has not been working for people, so if you go to YouTube and you just type in solar eclipse, you can see what this is talking about. So here's our mini anchor phenomena. This is a map of the eclipse. Think back, we all probably experienced the eclipse. It would have been when you were in 4th grade, I believe. It was when it got really dark outside in the middle of the day. So this is a map of the eclipse when the moon appeared to block the sun completely. Explain the map. Why does the moon appear to block the sun at 11:36 a.m. in Grand Teton NP, but at 1:28 in Nashville, Tennessee? So Tennessee is over here somewhere. Here it is. And the other one is all the way up here. So how come these two different places experience the same thing but at different times in the day? Give it your best guess here. We're going to answer it by the end of the lesson. All right. This outer circle shows the moon's revolution around the Earth. Here's where the moon is on its revolution. This shows Earth's rotation. Remember, it rotates on its axis 24 hours, rotates around its axis to create 24 hours. So that's how we have day and night. Here you can see that this shows the portion of the Earth that is receiving sun. So notice this part is lit up. That means all of these sections are having day. This part is not lit up. All of these sections are having night. Here we have the moon, and it is right in between the sun and the Earth. So these places should be experiencing day, but right now they're going to be blocked by the moon. That's what happens when a solar eclipse is happening. Predict. This picture shows the moon at 7 p.m. How will this picture look different when it is 10 p.m.? So if it's 7 p.m. here, will it stay in exactly that spot or will it move? Think back. They were all experiencing this at different times. Why is that? If you have access to the internet, use the demo in the link above to see how it changes. Again, that link doesn't work, so I wouldn't bet on that. What did you notice actually happens when the clock turned 10 p.m.? Select all that apply. What you need to get from this, if all of that was confusing, what you need to understand is these key points right here. The Earth is always rotating, so our perspective of the moon changes throughout the day. So this question asked you, would it look the same at 7 p.m. as it does at 10 p.m.? The answer is no. Our perspective of the moon changes throughout the day. As the Earth rotates, it will appear higher in the sky. So as Earth is rotating on its axis, there are times when the moon is going to appear higher in the sky. The eclipse occurred at different times because Earth's perspective of the moon changed based on its rotation. So because these places here are on different parts of the world here, as Earth was rotating, it was experiencing that eclipse at a different time because the moon was blocking the sun at different points based on Earth's rotation. Okay, so based on all that, you're going to practice with these questions. Use this image to answer the next 3 questions. Position 1 is 8 p.m. So this right here is 8 p.m. What makes it appear as if the moon is moving through the night sky? So what aspect of the Earth causes that to happen? How much time passed between position 1 and 2? What time is most likely if the moon is at position 5? What time is it likely right here? Okay, Mr. Lowe is talking on the phone with his brother on the west coast in California. He looks up at the moon and sees it shining brightly straight above him. His brother says the moon looks like it is more towards the east than straight above him. Is it possible for him to have a different view of the moon than Mr. Lowe? Why or why not? So, is it possible for Mr. Lowe and his brother to be in different parts of the country and seeing the moon in different locations? Here you can check your work. And here's the exit ticket. Observe the moon below. What accounts for the difference in the moon's location in this image? Number 2, the moon was high in the sky at location A, right up here, at 7 p.m. It is now 9 p.m. When would it be high in the sky at location B? Each location on the diagram experiences the moon high in the sky at different times. Why are they able to see the moon at those times?